Hello, everyone. I think this is working. Hopefully it is. And I believe I've actually gone live this time. So that's very exciting. Definitely let me know if anyone is here, if you can hear me. Because I am skeptical. Oh, no, I see it on my own page. Thank goodness. I see it on my... Oh, and there's a very low latency. How perfect. And the text is crisp, even in a small window. Maybe I can get away with making it smaller. Let's see if that's reasonable. Is that too small? I don't know. Let me know if this looks good or awful or whatever's happening. And yeah, yippee. I'll just take one moment to stretch here. And yeah, all right. Where did my windows go? Yeah, let's begin. So I am going to start out where I left off in the previous video, where to briefly recap, I want to build. Hey Matthew, how's it going? Are you the Twitter Matthew? Yes, you are. I'm secretly researching in the background. You're not as pastel posterized as your Twitter photo and your other thing. But welcome to my self-imposed Rust trials. Yeah, no pressure to stay, of course, since I believe you might be the only person here. I just want to let you know that I'm not looking at the view count, and you're free to come and go as you please. I don't want to punish you for identifying yourself. But thank you for stopping by. So I will talk to you and anyone else who happens to wander in here or watch a recorded video as to what the heck I'm doing, which is to attempt to impose my DSL tastes upon Rust, and that's probably a fool's errand, and it's going to punish me and make me conform to its Procrustean checking rules. But I'm going to give it a college try, and we'll see where we get. So last time I started sketching out some traits that are based off of SwiftUI's view DSL, which sort of looks like this in comment form, where you... Yeah, I'm sure I don't even know what kind of pain I'm in for. I looked at some more advanced code in the last couple of days, and I saw some crazy things. So I'm sure I'm going to suffer. It's just a matter of time. But yeah, I would like to achieve something like this, where you have this nice... it's almost like the Flexbox model of stacking some views vertically, stacking them horizontally. Leaf nodes, you construct this declarative tree in Swift, and they all have methods on them for, adding borders, changing the color of the text. I really like that DSL for views. Yeah, no pressure. Thanks for stopping. And I want to see if I can achieve this in Rust, and probably will fail, as I mentioned, but that's the goal. And it's inspired by me first trying to make a CLI and using TUI, a terminal library there, and being disappointed by their view UI, which I just see the colon. I see lots of colons, and I can't really, my brain doesn't parse this. It does not really represent the tree structure that I like to associate with views, that React SwiftUI style declarative UI definitions, DSLs. So that's what we're going for. And where I got last time was talking a little bit about my personal history, and someone asked me why I wanted to learn Rust, so I can skip that part. And then talked a little about how SwiftUI works, because we're going to be kind of stealing its API, its internals, as much as anyone knows about them, or as much as I know about them in particular. So we're going to have this view trait that's going to represent all of our different views, like text, like different directional stack views, padding views, frame views, other things that we can think of to modify these things. And it's really important to have a size method. I kind of went over that last time. And this is only called internally when rendering. Basically, parent views use this method. They call it on their children to figure out how they want to be laid out and how flexibly they can be laid out. But I won't go into that too much because I sort of did that in the previous video. So we're kind of picking off from there. And in particular, I've only made a text view so far, and I've made a padding view to sort of explore this idea of using generics instead of boxed children for maximum performance and monomorphization. I think. I have to learn more about Rust, but I think that's what's happening when you instantiate a padding view with a text child. There's not going to be any boxing involved, which is nice. So hopefully we can get this to be really declarative, but also really, I don't know, memory and efficient and performant, low allocations, and nice to use. And in particular, we ended with trying to construct, these variadic views like, I believe I started with HStack. And HStack, as I sort of showed off above, can have a variable number of children. Depends on how many things you stuff into it, like a VStack. How many things do I want listed horizontally? And 1, 2, 3, 4, 1, 2, 3, 4. But the problem we run into in Rust, and as well as Swift, is if we're just sort of naive about this, and I just say children, we're going to make a vector, and we're going to have to box all of our kids. And it's not, DIFUS will get called on us for boxing. I don't know what that means, our children. It's not very polite, and it's not very space efficient. Extra allocations are going in here. 2 pointers go into a dying trait. One goes to the data, and another goes to a map of all method call names. So for each view type, there's going to be a link to all the method call names. And so where did that go? So what I'd like to do is instead, the other option is kind of doing what padding did, where you have, V1, and that's child 1. And then if you want 2 children, it'll be V2. And if you want 3 children, you'll have to have all these different redundant, you'll have to define all these different variations just for each arity, every child count, which is a bummer. And so that doesn't seem very fun at all. And so but we are going to do something like that, just at a lower level, by constructing this view tuple thing, which is going to be a trait. And it's basically going to be exactly that thing that we just made, except it's going to be implemented for tuples. So there already is a type in Rust and in many languages. I'm glad Rust has it. That allows you to sort of pair up any arbitrary amount of types and retain their values. You have a 2 tuple, a 3 tuple, a 4 tuple, and you even have a singleton tuple in Rust, apparently, where you have a little comma after the first argument there, which I believe is not equal to just an A. Very different. And then I think we would have also unit, sort of the empty tuple. I'm not sure if actually that exists in Rust. I don't know. Does this exist in Rust? Who knows? Answer? Come on, AI. No. Okay. I'm going to believe I'm going to believe that autocomplete there. So maybe that doesn't even exist. I guess I'll find out. And so, yeah, we basically want to have each of these different tuples when they're inhabited by views. So, v1 and v1, v2, etc. No, not quite that. To all implement the view tuple trait, such that that's what can go inside of an H stack. And I can say children of some kind of view tuple. I'm second guessing how to even pronounce that. And therefore, there's not going to be any boxing at all. We're just going to have to pass in the right kind of view tuple, which will be defined as a tuple of views. So we'll just use sort of normal Rust syntax for that. And this is pulled from this library called RUI that I saw. And they did that there, and that seemed worth stealing from. I didn't look too much into their implementation, except for this sort of very high-level thing. So we're going to try to hack it from there. But I know it's possible. And not knowing Rust, it's good for me to know that at least this is theoretically possible in some library. And so our goal syntax will be something like, to make an H stack, it'll be H stack of, text, hello world. Except not quite this, because this has to be wrapped in a second redundant tuple, which I do not love. But apparently that's might be necessary, unless we want to go for either macros or maybe a whole bunch of overloads for the HStack constructor. But I don't think you can have overloads on method names. So I think that's probably the best we can do without using macros. And from what I've seen so far, macros have their own problems in Rust because you kind of lose autocomplete, and IDE support get significantly degraded. But I could be wrong there, and maybe there are ways of making that better. I kind of got some autocomplete. It was just weird. It's certainly worse than normal. So how do we do this? So let's start with a situation. Basically, we want to impl for v1 being a view. Let's see if we can do this. If we have a singleton tuple, for v1, there we go. It's got it. I'll just let it complete this. Cannot inherit impl for a foreign type. Because I haven't said view tuple. Okay, I don't know what they mean by foreign type, but sweet. There's one problem here. Cannot mutate immutable variable f. Okay, I think I need to fix that somehow. Oh, because that is, might I need a mutable reference to that? Will that make it happy? All right, that made it happy. That's the kind of thing where, from what I've seen, even people who really know Rust, they kind of just code something, they get an error, they hover over it, and they're like, oh, okay, let me do what the compiler just told me to do. Because there are many subtle variations of ampersands and mutes, and sometimes stars and all sorts of things. Aha! 128 tuples out of the box. Take that, Scala 2. Holy mackerel. That's crazy. Oh, no, yeah. They have a lot of overloads. So yeah, let's have we have a couple of options for writing this. I don't want to just pollute this buffer with a lot of stuff. So AI is great. Pretty amazing. This is the first, when I first used what was it called? Copilot, back in the original beta period. And it could do this in generic Scala code. It blew my mind, because this is so much of generic Scala code. If you're doing like tuple zipping, tuple flattening, when writing zip combinators for some special DSL for quality of life, you give quality of life to the user, yet it's like the portrait of Dorian Gray. You're just dead inside. They might have a beautiful portrait of a young Renaissance man, but you're a decrepit fool for implementing 22 different tuple overloads of some zip method. So anyway, this is not very nice to do. So it would be great if there was some way of abstracting over this, just for our sake, not for the user's sake, just for us. The errors stop being nice in async land. Yeah, I guess I'll probably eventually try to make this async friendly. I kind of avoided that so far. It's definitely not necessary for this very simple app that I was originally testing it out with, but I would like to explore async Rust, especially being a fan of Scala's async libraries, would probably have like the highest quality of life. Yeah, I'm sure just going from back-to-back Rust async to Zio and Scala 3 is a truly shattering experience. Yeah, I mean, I could well, I don't want to sort of just go through my OpenAI budget by telling it to go up to 122 different overloads. And also this editor is it is based on VS Code. It's not Z, so it might get a little choppy. So instead, I am being a fan of macros in general and wanting to understand Rust's macros. I mean, AI is just so good these days that I could say, I could probably just get a thing to do it. Yeah, let's just see what it does without really any examples at all. Just, can you write a macro that helps me define these for any arbitrary number of views? Hopefully it can do that. Hey, Yassine, welcome back. And we'll see what it did. It seems to be a little sad. Convert the identifier to snake case. Because it's not an identifier, it's a type, right? So yeah, from what I understand, so far, just kind of glancing at various macros and having AI generate macros and then looking at them, it's kind of like a crazy regex, crazy regex syntax. Like regex, it's like pattern matching on crack in a time machine or something. Because we're in like a match at least one block, and we've matched this name, which is an identifier, and many of them, because we're sort of, that's like a capture group of that thing. Then when we use that identifier inside of a capture group with, I guess with plus, it's going to do that as many times as there are the name. I don't know if you combine it with another pattern that you're capturing, if it's going to like be a sort of a dot product of these captures. It's very confusing looking. And I don't think this is exactly what we want for multiple reasons, that this seems to be wrong. But I will hit this error button, I think, yeah, fix in chat. Let's see if this works. Allow non-snake case. But I think the macro is wrong in general. So I'm going to, let me just prod AI once, just for fun. I think this macro is wrong. I think I need both a list of types and idents. Maybe? Yes, I'm correct. Oh, it complimented me. Even though it didn't seem to change anything as far as I can tell. It looks to be identical. It just added one more. So yeah, thank you. What does this compile to? Do I have yeah, I'm not even sure really how to test this. Oh, I know what I can do. You can inline macros, which is a pretty cool feature, I guess, of the Rust Analyzer, which I really wish Scala had. Swift has it's basically the same thing, except just you could preview the output. You can't, I don't think, inline it. And yeah, that's pretty great. Okay, so that's why it's sad. Oh, wow, so that error got propagated. And cool, so it's pattern matching on self and then doing that. That seems great, honestly. That almost seems better than what I've seen when I looked briefly at the other RUI library. They have to pass in a whole bunch more operators. Maybe I'll just allow snake case. Where was that thing that it said? Allow snake case. Warn non-snake case. Yeah, how do I add that? Can you turn off non-snake case warnings inside of the macro impl? I don't know if that's possible. Yeah, maybe. Let's see. Give it a shot. Oh, that is insane. And so a way to test this, I guess, would be to, well, obviously, select this and say, can you write some tests for this? Boom. Please. Wow. It's writing tests. Almost too many tests. Maybe I should have macros generate the tests as well. That would be nice. There'd be nice symmetry there. There's all the tests coming. And that new Omni model is real quick. It's very nice. And of course, it's deeply broken. Cannot be applied to view size because partial EQ. So that actually makes sense. So I had this type size, which is just a width and a height, and I need to derive a whole bunch of things. I guess derive debug and clone, and I don't know. I'll do it all. Let's go. I'm not sure if I want to derive copy. Copy, I still need to figure out what that really does. Oh, it's simply a macro generating an impl of the trait copy. That's very helpful. Okay, yeah. I'll have to look at a real copy. Oh, that's probably a copy. Types whose values can be duplicated simply by copying bits. By default, variable bindings have move semantics. But okay, this is so simple maybe that you could just copy bits. So yeah, so an LSP, yeah. So I'm using here, so good question. I'm going to set up a Rust environment this weekend. What do y'all recommend? Hello, LB. Again, by the way, pound. He showed up at the end of last night's session. So welcome back. I'm using this thing called Cursor, which has all this fancy AI shortcuts. It's called Cursor. It's really good. It's fairly amazing, having used VS Code and IntelliJ and all those other AI interactions. This one is a few orders of magnitude better. It's really impressive. So I recommend that, actually, instead of VS Code, but it's basically a fork of VS Code, so that will work. And then I believe I just use the official, like, to search for the highest rated Rust thing. It'll install the Rust analyzer and whatnot. I did not have to spend much time setting this up. It kind of just happened. Unlike Scala, yeah, I have installed this. I don't know why it says I haven't. Or I haven't installed this like group of extensions, but I've installed them all individually. So I guess I'll install the group, and that should hopefully be a no-op. But anyway. Yeah, so that's what seems to work for me. It's been working so far. Zed also seems really cool. It's an editor written in Rust and is really fast and is open source and is cool. I've just fallen in love with these AI things that I have trouble. It's just, especially not knowing Rust, I need to rely on this a lot. Yeah, oh no, Cursor is amazing. It's really crazy. All right, so now all these tests are passing. I don't know what the tests do as usual, but I will run them. And then if it makes green colors appear, I will investigate further. Okay, so it made green colors appear. So let's see what we have. I have a test view. Oh, that's weird. It made a test view struct. That, I don't know, it could have just done text. Showing off a further cool thing, you can select some stuff and say, don't use test view, dummy. Delete that. Just use the simple text view. So it deleted the text view, and then it's just using the simple text view. And it's just deleting all that stuff that it did. Oh, but it is checking the size of stuff too, which is cool. So maybe it was nice to have that other more complicated view. That was like testing too much. I just wanted to make sure that tuples work, in fact. And it seems like they do. So what it did is correct, which is crazy. Until I just told it to do what it did. Something panicked. So I've broken something. Let me undo that then. My implementation of text is probably incorrect. I haven't really gotten into testing that. But if these tests pass, the only thing I really wanted to see was, let's go to a double tuple view. So it's making two of these test views, putting them in a tuple, and then it is calling for each on the tuple. And that works. And because that works, that must mean our macro worked, and it created that instance. I wish it were possible to know exactly how this for each was synthesized. It's not entirely clear at the moment where that's coming from. Oh, I guess actually it is. I command clicked on it, and that's amazing. Okay, that's pretty good. So it knew exactly which macro generated the, let's go to the for tuple, quadruple tuple. And if I click on this one, it should show the impl view tuple for. So that's pretty impressive. Yeah, Scala is amazing, but it's just locked away from us. It's getting the tooling set up is just a bit of a pain. I have to restart middles all the time. Ha 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 ha! I know. I'm just burning compute, and I'm using it so much. It's just so evil. Yeah, and seeing that whatever that V was it GPT-4 Omni thing, and people are just going to talk to that all day and make it do stupid voices. At least that's what I'm going to do. And that's going to kill a lot of things. But that's why writing Rust is right? Isn't that supposed to be environmental because it's so efficient? I will balance things out. I vaguely remember something about, many initiatives often backfire, unfortunately. I'm probably completely wrong because this is like a memory that's lodged in my head, and I should validate from, I think, like middle school or something. Some teacher told this anecdote, which is that at some point, cars were causing a lot of pollution in the 20s or the 30s or at some point, and then regulators came in and said, we're gonna have to make this more environmentally friendly. Somebody invented the muffler or something. I don't really know what a muffler does. It makes things quiet. Maybe it also has an environmental impact. Maybe it was some other. I'm not a car person or very mechanically inclined, but apparently it worked. It made the car more efficient, but then it also allowed there to be just way fucking more cars, which totally negated any benefits. And that who knows? I don't know what the leanings of that teacher were, or what they were trying to tell us, if they were libertarian or anti-regulation. I don't know, but it was just an interesting phenomenon that does occur. Sometimes the cure has unintended side effects. Hello again, Yash. That actually might happen later this year. Very excited. So yes. Anyway, where is this? Okay, so yeah, these tests work. I don't really care about them. I'm going to delete them. I just wanted to make sure that those macros worked. So that's kind of the plan. We can just do that and get a whole bunch of implementations. And hopefully these implementations, I'm so glad you can inline them, look reasonable. I don't know if this pattern, I'm guessing because it's Rust, this pattern matching is zero cost. And because it's, infallible or what have you. So we're just calling that function with each item. I would think that instead of the for each method, maybe I should have a to iterator or something. But this is what I saw in that RUI library. And maybe once I understand more, add more to this. But now we have tuple views. So now our H stack can be comprised of these tuple views, and we're not going to have to box anything. So that's the cool part. But I want to still keep working on sort of ergonomics, because that's kind of the whole goal of this. Ergonomic, yeah, okay. Which is, I just want to write something out that I want to work. So I want to say basically vstack, and I guess I need double parens, unfortunately, to do the tuple thing, and then just say text a bunch of times. So fn text, fn vstack. And for this, I think I'll need say it's a tuple view, and I don't think I've defined vstack either, actually. So struct vstack is that, and then I'll say, is it let cool equals that? Will that be happy then? Oh, it needs a semicolon, of course. I really hate the semicolon. Oh, take care, Matthew. Thanks for stopping by. That was really fun. All right, so this is the ergonomics and it seems like it'll kind of work actually. Which, I mean, looking at that RUI library, I was hoping it would. We're just instead going to write this for a terminal UI instead of for a full-blown graphical user interface. Way more practical, at least for my purposes. So yeah, and then you can have an H stack in here, H stack, and put those. So two different rows. So item 1 is eggs, powder, milk. And then, of course, I'll need an H-stack. And this is sad for some reason, because tuple2, I failed somehow, probably because of this. Why is this so sad? VT is not satisfied. Oh, because it has to be a view tuple. And something is still sad. This is sad. The trait bound, oh, I don't think I've implemented view for these things, which they need to be in order to go inside of, in order for this view tuple to be a view tuple, each of its elements need to be views. If that's not obvious, let me inline a macro. So each of those v parameters need to be views, and h stacks and v stacks are not views at this point. I need to implement view for them. But also because they're basically the same thing, except they go in a different direction, I'm going to make an enum, a direction enum, either horizontal and vertical, and then we could just have a stack, and then have a direction and children. And then h stack and v stack can simply construct a stack with a new direction. And then I can implement view for, not view tuple for stack. Oh, wait, no, that does make sense. So if the VT is a view tuple, but that's already a requirement. I guess I have to say that anyway. And something sad here. Mute expected unknown closure. So I don't know what's going on here. So therefore, I'm going to ask AI to help me. Please solve this. And that's really confusing. Ergonomic. Oh, yes, that needs to be closed. Okay, it's not correct. I don't think that would be correct. Expected unmute known closure. I don't know what that can mean. And I don't really even want to do anything that complicated. In fact, it's going to be difficult to size this thing right now. Let's say sum the sizes of the children in the direction of the stack. I guess. And in order for that to work, I might want to have another sort of helper method here. And that's actually one thing. I don't think you can have like private helper methods. Everything that needs to be in this impl of view needs to be a view method. So if I wanted a private helper method, I'd have to define it somewhere else, which is a bit annoying. I guess I could define it in here probably, maybe. Value for direction, and it would take a direction and a size and get a value out of there. Okay, I guess that'll work. And then I'd need to have a let mute of result, and then do that. And that seems reasonable to me, but I'm clearly doing something wrong here. Expected mute unknown found closure. So I'm going to pop this over into the AI chat, or say, what is it, Command-Shift-E, and it'll tell me this. The error... Yeah, you can define methods outside of the type. I could just do a top-level method, but I just care about this for this implementation. So I guess defining one in here seems to do what I want. Though if we have a lot of those, it could get a little noisy. So this error occurs because the closure passed to for each expects a mutable reference, but the method signature of for each does not specify that the closure should take a mutable reference. You need to change the closure to take a mutable reference to the child. So what is it doing here? Self children for each child. I don't see what did they change there? I think what's going on is that yeah, maybe, but I don't want it to mutate the child. In fact, I just want it to. Is this right? I feel like feel like maybe the signature is wrong here. Can I just do that? That seemed to work up here, but then it wouldn't work down here. For some reason, I believe. Cannot borrow as mutable. Cannot mutate the immutable variable x. So maybe I'm going to pull this into the chat because maybe this can be fixed. Oh, it just says mute? Mute F. Oh, that's interesting. So I need to say mute F and then like that? That doesn't seem, I don't think that's real syntax. Remove mute. Patterns aren't allowed in functions without bodies. Oh, okay. Well, but I can do that here? That's super crazy. I don't understand. Rust has confused me. Also, this should not be expanded. So that was useful to see. Is it sad somewhere else now? And then the result is the wrong thing, because this should be a size, but it's a result. So let me think of how this could work. I guess I kind of want the result and then max to be the other direction. So I'm going to have a method on impl direction saying next. And then I can make the max equal to the next direction. I don't know if that'll work. That'll at least get us out two numbers that I can turn into a size. Oh, and then, yeah, it's hard to make this generic for both directions. I probably should have just done two different definitions. Value for direction, this should be borrowed, right? And then I need to have an ampersand there. Nice. I just want to get things to compile real quick because I've added a lot of advanced things, more advanced than I understand. So I'd like to experiment a little bit and figure out what the heck's going on. Because yeah, the fact that mute pattern apparently works for a function with a body. Mute can be used in several situations. The first is mutable variables, which can be used anywhere you can bind a value to a variable name. Oh. So what, it sounds like the value isn't mutable, just the variable is mutable. So I'm overriding that, but I'm not setting that to something else. So I don't really understand what that's about. But, I'm okay to, a great tactic is to just ignore those things and assume that I will be exposed to more things later. And maybe other parts of the language will help me backfill that knowledge once I've struggled some more. But I will note, maybe I'll make a to-do. Where did I define the @mute? Note, what's the deal with the mute f? Yeah. So I guess the mute fn mute thing is the same thing as func var x equals x. Yeah, that's what I would think, where you kind of, from Swift, exactly. But I don't see why I needed that, because I don't think I'm borrowing f as mutable. Oh, of course I am, because not of course I am, because this whole fn mute thing is very confusing to me, but the function does mutate itself, so it needs to be a mutable fun. Maybe there's an example here. Using fn mute parameter. Do twice. Oh yeah, that's how they do it. Mute. They put a mute there. That's great. That's confusing. I don't know. I've never seen mute in that position before, and that just seems like a strange... I got to understand that more. But anyway, at least it's in the docs, so I'm not doing something insane here. And I guess what I probably want to do here is actually, to get it actually correct, even though this is probably still wrong, is I can get the direction, what is it, match on direction, and let me think about this. So if we're laying it out horizontal, I want the width to be the sum of the children's widths, and the height to be the largest one. And so the other way around. And if I'm laying them out vertically, the total height is going to be the sum. I should rename this just to sum and max. So anyway, this is not the best method, and I will also re-implement this, and I don't think this is correct. And we're actually going to want to make stack way more interesting and complicated. And in fact, we're not even using the proposed size, so this is just totally wrong. But I wanted to see, I don't know what I wanted to see. Let me just delete this and just return proposed. Let's just return the same size. That might be fine. And we'll figure that out later. Move on to more interesting things. Stack views are a little challenging. It would be great, actually, to sort of force out some more functionality, and something a little more visual here is to actually start rendering things. And maybe just using padding and text to do that. Oh, and this is actually something I want to figure out, how to get dot padding on a text node. So we figured out in my little ergonomics example that we could achieve something reasonable. But what if we wanted to add some padding to our entire list here? We wanted to put padding 2 in all directions. So how do we add a method to this VStack here? And I believe the way we can do this is this crazy little trick. It's a method we want to add to views. So I would think I could do something like fn padding, and then we would return, maybe we can have like an actual implementation where this would actually be a padding node around self. But this is sad. The size for values of self cannot be known. Okay, we need this. We need an implicit sized bound in view padding. In view padding, consider further restricting self where self is sized. So I don't exactly know where to put that, so I'll say add where self is sized. Okay. Mismatch type parameters. And in this case, yeah, this is another case where we're going to have to think about the memory model, because I've learned a little bit more about ampersand versus no ampersand. So ampersand is that it's borrowed, and so yeah, just whatever. That string is or whatever, some kind of type is borrowed, just type is owned, and of course there's like the mute type is mutably borrowed, which means there can only ever be one of those at a time, and you can't have immutable borrows as many as you want. Only one. I'm not sure if you can have an at mute in this position, though. That might only be for functions. Anyway, what the owned thing is that this, like it all comes back to the magic of Rust not having a garbage collector and not having arc be the default, like it is in Swift. You can opt into arc in certain situations to make sharing values easier without cloning them, but this is how Rust does it with all its static information in the borrow checker. And so if you just have a value, wherever that's assigned to, whoever owns that value, when that thing goes out of scope, that thing will be dropped. It'll be deinitialized. And so, you've got to be very careful that you can lend out references to yourself, but the things that borrow you can't outlive the thing that owns it, because that thing it's going to go away when the owner dies, and therefore those references would be dangling references. And so there's something about lifetimes we haven't even gotten into, which ensures the fact that that is the case. But because that distinction is important, you have to kind of decide at every point, do I want to borrow this value, or do I want to own this value? And if I borrow it, I think I need to give it a lifetime as well. I think we want to own it. And because of that, I think we're going to do, we're going to make this thing clonable. And when we pass ourselves along, I mean, there's two options. We could pass ourselves along in an owned way, basically transfer ownership to this function. When you call padding, you lose yourself. And you get owned by this thing. That is one way to do it. Or we can have this clone ourselves here. And I should probably say these need to be clonable. And then I could do that. So those are two options, and I do not know which one is more idiomatic. So I will ask, and this is sort of the pain, probably, that Matthew Fournier was discussing before, foreshadowing of Rust, where it's like, yeah, it makes you deal with some stuff you probably aren't going to want to be dealing with in normal code. And this is why, I'd probably just use Scala or Swift or something for a more high-level experience. But trying to stretch the brain, I would like to understand these consequences. So, I'm going to ask AI and say, this is what I've been doing for the last few days. Is this idiomatic? Is this idiomatic, please, Robot Overlord? It is. Yay, it's idiomatic. Well, anyway, I'm going to stop that. What about if the self in padding is just self, and we transfer, and we move, that's the terminology, we move the value. It is tempting to keep going lower level. I've just been flirting with the depths. The depths. Okay, so this approach is idiomatic and can have some benefits. Move semantics. By taking self by value, you move the view instance into the padding struct, which can be more efficient as it avoids the need to clone the instance. And you transfer ownership. Both are... okay, both. The answer is both. Great. Let's quickly try to transfer ownership, right? Because that's more efficient. Does that suck? What are going to be the API trade-offs? So then I won't need to have this clone bound on view at this point. And we can see. In this case, it's totally fine. But I think where it would stink is in the following case. So what if I just have let my view, and then I say my view.padding2 let padded 1. Oh, I'm doing colon instead of semicolon. So far, so good. But then I do padded 2. And so now it's sad. Because I've already moved it. But now that I think about it, if I really wanted to do this, and this is probably not so common, where you take a view and then use it multiple times like this, in this way, you can always just clone the first view. So if I make just stack clonable, derive, let's do the derive clone on this fella, and therefore we also need to derive clone on direction. And let's add debug and stuff. I know that might be useful. The clone exists for struct, but its trait bounds were not satisfied. Method clone not found for the struct because it doesn't satisfy clone. Let me add clone to the view, and then that'll make sure I add it for everything. So struct text, derive clone, and then for this, derive clone, and then for... Oh, VT clone is not satisfied. Oh, interesting. Yes. How would I do this? An end clone? Or I can say view tuple. You know what I could say? View tuple. Yeah. View tuple is clonable. Which it should be, because all views are clonable. But that's sad. View cannot be made into an object. Wow, why did that happen? Oh, because I probably need to say, no, it's a view. And, oh, that's super weird. And that's also kind of cool how these errors propagate to this position. Let me inline this macro. The trait view cannot be made into an object. The following types implement this trait. Consider defining an enum For a trait to be object safe, it needs to be allow building a vtable to call to be resolvable dynamically. I do not know why adding the clone requirement has done this. So that's kind of crazy. What if I do plus clone here and remove it from view and say, okay, fine. The view thing doesn't have to be clonable. Where'd view go? View. View. So view doesn't have to be clonable. It just so happens that all of the instances do it. View tuple. Move that there. And then stack is clonable. So yeah, very strange. Okay, I'm going to undo that. Yeah, this is a bit of a corner I've painted myself in. I didn't think we would end up in this place, but this is what happened. I might need maybe I'll try the other pattern. Ooh, yeah, that's really not a fun. I'm gonna ask. I'm gonna ask it for stack. Okay, but it already does have it. Stack is already deriving clone. Ooh, that made it sad. Clone was not satisfied. Let's check this out. View tuple plus clone. Okay, well, that's what I tried. But then I need to add it everywhere? That's so painful. And then it still doesn't make it happy. Because I guess I need to add it to all of these locations. And then it's still sad. Oh, I think that's because now text needs it. So I do need to just implement it everywhere. So maybe that's how I can do it. And it's happy now. It's happy now. The clone journey. Yes. Yes. It just all hit me at once. I don't know. I thought I understood. I don't know why adding the clone constraint to the trait breaks this. So I'm going to ask, add this to the chat and say, how do I get this? Why in the world would adding clone as a constraint to view clone, why in the world would adding cause this error in the macro? Please tell me. Oh, what? The error occurs because the clone trait is not object safe. In Rust, for a trait to be object safe, you need to be able to use it as a trait object like dyn view. It must meet certain criteria. Oh, and I guess, yeah, we are using it as dyn view here, and yeah, when using it in this case, we do have to put all of its method call names into function pointer. We need to build a vtable for all of its methods, and I guess it doesn't know the clone methods. So apparently, another solution is to just, it's kind of annoying because in reality, every view will need to implement clone for anything to work. I guess we can just make sure of that. Hello, Strongly. Welcome. I just went through my clone hazing. Attack of the Clones? Yes. Attack of the Clones. And I feel like I still don't... I mean, okay, I guess that tracks. It's just annoying that unlike Swift, unlike Scala, where yes, I want Vue to have a clone, I can't put the clone there because that has other implications and it will prevent the optimizations that I want to be able to take advantage with in Rust. Otherwise, why am I using Rust? It's just as a worse version of Ruby on Rails, that would be really silly. Cool. Anyway. So I guess I'll just have to make sure that everything is clonable, which we will as long as we have tests that will hopefully become obvious. But then you also have to mark these things as all clonable. I could just imagine a whole bunch of... What if we need other constraints? I'm gonna ask the AI and chat, if anyone is here as a master of Rust, is this possible to avoid? It seems like now I'll need to propagate plus clone everywhere because it is an actual requirement of Vue. I just can't put it on the trait. So I'll have a bunch of boilerplates like this. Is this avoidable? Please send help. Yes. No, I don't want to box it. No, that doesn't, that's no. Oh, wait. No, that doesn't really do what I want. Nope, I don't want to do that. Any other solutions? Okay. Okay, I could use I could use macros to do it. All right, yes. Okay, so anyway, maybe it is possible, but AI is giving me really, truly awful advice. So I'm not going to use macros to define literally every struct in this code base, despite the fact that Rust seems to be totally cool with that. And I love macros, but that just seems one step too far. This is not immediately readable. Though it is nice that you can inline them, and that actually does really help me. Between AI doing all the heavy lifting and being able to just look at a bunch of examples, man, I wish I had all these tools when I was learning the code. But then I guess I'd be learning the code right now, and then we only have a few years to live, I guess. So I don't know. So anyway, so that seems to be reasonable. Now I've made padding move itself. It moves itself into the padding. It just jumps, it hops into there. Very cozy, ensconces itself into the padding. What a fitting type to cushion it. And if we do want to do this sort of maybe not enigmatic pattern, maybe not too common, practically speaking, pattern of predefining a view and then using it in a bunch of places, then we can clone it. Why not? Because at least we're not cloning it every single time. We're only cloning it when we want to do this. Not as nice as, Swift, where you don't have to think about that stuff, but it's faster, I guess. So yay, we achieved that syntax. I actually didn't even think that was going to be possible. I've seen a different version of this where there's like I forget what it's called, view extensions or something. I'm going to once again, what's the pattern in Rust for adding a bunch of extension methods to a trait that all have concrete definitions? View extensions, yes. So you make a trait view extensions, then you sort of have this dummy implementer. So what would be the difference? Any material difference between... You know what there might be? Thinking about the dyn thing and that lookup table. I probably don't want to put a bunch of methods onto Vue that aren't actually core to Vue. And that could just be added later to any view. These are sort of any view methods. Hey, Matthew, you missed the most painful part. I may recap it. Let me just ask AI this last question. So any material difference between that pattern and simply loading up the initial trait with concrete methods? Tell me. Is organizational. Okay. Won't putting these on the initial trait bloat the dyn trait lookup table thing? Yes! Oh, I'm going to bloat that V table. Performance implications. I knew it. Using extension traits. Let's do it. A trait. Actually, why am I doing that myself? I'll just click on the button and have the UI do it, or the AI. The AI, it's UI do it. Ba-ba! So now the extensions have been pulled out, but everything still compiles because Vue implements Vue extensions. So when we call it concretely here, it can figure out at compile time what method we're actually trying to call and just sort of dispatch directly, statically to this method, versus every time you refer to a dyn view, it having to pack that into the V table. Yes. So Matthew, the pain I learned before was the following. I'll briefly recap it, and maybe you have insight here. Oh, what's the size trait? Oh, totally. I just kind of skipped that. I was just like, yeah, I'm just following what the compiler tells me. And that is originally why I found out about that. So let's do a brief... It's different than my size, which I made myself. Sized is types with a constant size known at compile time. And I think that's necessary here. It is, and why it is because of, I think, that reason that it's not being boxed, and it needs to be... Yeah, I don't know why that... You don't need to say it here, but you do need to say it there. But that is the whole point of what we're doing here, is that it's creating this crazy type of... At compile time, it knows exactly which instance of Vue, which monomorphic implementation of the Vue trait is going to be used, and so it can allocate just enough memory to create and store a stack of text, stacks. And then, okay, it doesn't know the size of a V. Yeah. So it's just telling you, yeah, you can't just pass in some random thing here that we don't know, I guess. It has to be known. I'm just registering it currently, and my brain is, yeah, sometimes you'll need to put plus sized in places, and that'll fix things. And at least the compiler tells you in this case. It's just like, yeah, you're going to want to do exactly this. And it's like, okay, there you go. Moving on. So the pain I ran into was that I want to be able to... So yeah, I was trying to decide, and maybe you have an intuition of what is more idiomatic in Rust. I'm just constantly seeking idioms. I am a traveling ascetic going from village to village in search of good idioms, because Scala has left me unslaked. That's not a word. Where did it go? What am I? Oh, padding. Oh, that new padding method I made. So with padding, I have two options here. I can either put a reference to myself. I can borrow myself and then clone myself and throw myself in there, as long as, of course, I said that Vue is clonable generically, or just did, clone here. Or I can move myself into this padded area. And I decided to go with that because I could always theoretically, like down here, I made an example of where this would matter. It's fine if I just refer to myself once, or just, chain, if I chain it, as you usually do in SwiftUI, just chain these methods, these so-called Vue modifiers, as they call them, just a method. Then that's going to borrow itself. It'll be more efficient, really, right? It's just hopping along there, no copies. But in the rare case that you do want to define a view and use it multiple times, you just need to clone it. And in this case, by not having Vue inherently be clonable generically, I can just kind of clone it in an ad hoc. Sorry, by making padding not clone itself, I can just clone when I get into the situation because, hey, it's Rust and I want to be performant. But I was thinking, maybe because of the fact that I want that feature, I probably want all my views to be clonable, so let me add that as a sort of constraint here. And then I got this really crazy method error down here in my macro, which is kind of it's kind of interesting how that error message it's generated by the uses of the macro, but it knows to ascribe it to that general pattern area, and I guess it's going to aggregate every single instance of that, which is pretty good ergonomics for macros. I'm really impressed. It's not hygienic, but it is nonetheless impressive. And so apparently the reason for this, according to AI, though I would like to consult a flesh and bonesman, such as yourself, Matthew, as far as I know, I think you're not an agent, is that it can no longer pack it up into a dyn, into that dyn view here, because it doesn't know the size of the clone implementations. So that seemed unfortunate to me, because that is like a reasonable constraint I would want to add to view, because it is something that I need to basically make sure every instance derives clone, but that's kind of fine because I'm mostly going to be either directly operating on those types where I know exactly what they are. So of course it knows it's a stack, so I can call clone on it because I've derived clone for stack. Or in these cases, now I need to specify every time I take a thing that it's also clonable, which is pretty annoying. So there's this clone propagation, aptly said, the attack of the clones by Yash. Or Yash. I'm not sure how to pronounce your name. Feel free to correct me, and apologies to everyone whose name I brutalize. And correct me if it's not Matthew as well, for that matter. Maybe it's... I'm not even going to speculate. Yeah, so that's it's painful nonetheless, and it's a little sad. And I'm imagining if we're going to have other protocols, we're just going to have to pile up a whole bunch of protocol addition or trait addition. I'm using Swift terminology now. All right. Yes. So cool. Anyway, I feel like I'm slowly understanding a little bit more. What was the error though on the macro? Oh yeah, so I can bring that back. So if I put, it's a really bad error. It does not tell me. It does, unlike most Rust errors, it does not command me to do its bidding and just make a change. It says the trait view cannot be made into an object. And then it gives me some useless information about things that can maybe be made, and then it says maybe you want to make view into an enum, which I don't want to do because I think that'll have a cost to the lookup table, the switch table of each of the cases of the enum, versus just sort of monomorphically knowing exactly which one it is at compile time. And yeah, but apparently it's required for the cast from the view to this dyn view thing. So in order to make a dyn view, there's something about it that doesn't allow it to be an object. It's not object safe. Yeah, exactly. So similarly, I probably can't do... We could try that, but I'm guessing it's the same situation. So that clearly doesn't work. And I probably can't do it here either. Yeah, it makes this sad now. Yeah, I mean, I could do this. I'd have to say plus clone here, I guess. So maybe that's okay, actually. And then all view tuples are clonable. I guess that's okay for now until I want a dyn of a view tuple, and then I might regret this. I've heard of these sorts of things where Rust causes you to make that refactoring everywhere. I think that's probably the well, when I asked what the AI said about object safety, I think is in one of these things. Yeah. So I asked, why in the world would adding clone as a constraint to view cause this error? That error. And then it's explained that the error occurs because the clone trait is not object safe. In Rust, for a trait to be object safe, i.e. for you to be able to use it as a trait object, like in @dyn view, it must meet certain criteria. One of those criteria is that all methods must have a known size at compile time, which clone does not satisfy. To fix this, you can remove the clone constraint of the view trait, and if you need cloning functionality, you can implement it separately or use a different approach. And then it gave some stuff I didn't want to do, and then some other stuff I didn't want to do that looked crazy. Compile time it's the best time. It's the best time to know. I love compile time. I live for compile time. But anyway, besides all that weirdness and definitely some funky things, and I'm afraid of the future that's coming when I just add another feature and I have to change everything and delete this probably, and remember that I have to do other things. And I hope the chat shows up so it just doesn't seem like I'm laughing maniacally at myself when the video is whatever released. Also, thank you all for being here. It's very nice. It's way less isolating than usually. I just record these lonesome videos and they take forever, and I'm a perfectionist, and I can't be a perfectionist here. I'm probably using too much and other, just not being very eloquent in general, but it's freeing. So it's really fun. I'm a streamer now. My fate. SpongeBob case. We never used that. We have to test that at some point. But anyway, the point is that this works. Yes, refactor, rewrite. Yeah, I'm not so versed in the visitor pattern. Refactor, unsafe, not simply complex terminal UI. Perfect. Rolls off the tongue. There's another one of those uhs. Okay, I've got to hear myself say that and become a better speaker. No uhs, just silence. Comfortable silence. That's hard. That's really hard. Okay, anyway, so the API is looking okay. So now we want to render it. That's what my brain is falling apart. I didn't get much sleep last night, which should hopefully has a loosening effect. Brings out that liminal state of clarity and pellucidity. Oh, I was not fishing, but I caught a big one. Thank you, Kaiser. So yeah, this seems to work. So I want to now render views to a buffer. So we must make buffer now and get out of this whole macro view tuple thing. We've proven that it vaguely works, and now we want to render some stuff. And I should definitely clean these things up because there's a lot of just going up and down. Feels a little chaotic. So let us actually do something. I want to render to the screen. I want to maybe make a test. And I don't know the syntax for this. So make an empty test mod here and instantiate a padded text node in it, ripe for asserting upon. Beautiful. Oh, it even did assert upon it. But it's doing things that aren't quite correct. Why is this? I don't even know what it's doing. Borrow of moved value text node. Oh yeah, so I can't clone after the fact. I have to clone before the fact. And there we're happy. So clone early, kids. And I don't know if this is I don't know what it's doing once again, but it passes, which is great. So I'm happy. Commit to master. Or main. Text node hello world. So it's padding the text node just as I asked for it. And then it's creating a proposed size, sizing it, and then making sure that the size is 1 + 6, which is, oh no, the width is the size of the text node plus 6, which is the padding size. Yeah, that's great. It is sized correctly. It makes sense to me. 1, which is the height of the text, plus 3 on the top and bottom. It even Oh yeah, it's time for an impl display. Well, I'm not sure if I'm going to impl display actually. I guess that would be okay, but I want to maybe have a haphazard way of getting there, right? That's just like that allows you to turn the thing into a string, and we are going to do that. But I think what I want to do is make a little stealing. This is where I'm going to steal from what I've half remembering from the Ratatouille library, which is going to basically. So yeah, we're doing a terminal thing. That's the goal here, and so we're going to have. Let's have some numbers. I forget where is the XY coordinate in ANSI and an ANSI terminal. Where is the origin on an ANSI terminal? So yeah, use superstar. That is basically import everything from the above module, which is this file. So we make, the way tests work is you make like a little submodule here, but then you have to import everything from the above context. Otherwise, they don't have access to anything outside of these boundaries. So we're just kind of saying, oh yeah, let's suck in, vacuum up all of the definitions from above. And I really kind of like this built-in test syntax framework, even though I hate when these things fail. Those error messages are really awful. It's just like panic, panic, gray, 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 and it's easy to miss the actual assertion failure here. I imported a library called pretty assertions, and then that's going to override that assert EQ method to have colors. So even though you still got all the ugly panics, it's easy to not miss the difference here, which is good. So then I can make that 7 again. Oh, true. Yeah, it reaches out into any parent module, and the whole organization of these things took a minute to understand too. I'm not going to get into that because it's kind of boring, and it's I don't know. You probably just have to make a couple of files and screw around with things to get a handle on it. Yeah, Rust does like to panic, as probably an homage to the Hitchhiker's Guide or something. Yeah, I like that they have the result type, but yeah, I haven't even really messed with that yet. I don't know if it's going to be as safe as the typed errors of Zio or what exactly. I'm guessing it's not going to quite be as nice, but we'll see. So yeah, this is great. We have a test area here. The next thing I'd want to do now is actually render this, and basically assert that I'm going to duplicate this. Rendered padded text test rendered padded text. And so instead of doing this exactly, maybe I'll make it, let me make a much simpler thing. I'll just say, wow, or Rust, and padding 1. And so that's 1, 2, 3, 4, 5, 6. So this should be 6 by 3. And now I want to, eventually I'm going to call something that's undefined. How do I throw? Panic, right? Panic. Can that be anything? Panic to do. And I'm going to make this a string. Does that work? Yeah. Result. And so let expected. I'm going to make a vec of... Not quite that. I'm not going to have that. But it is going to have just one amount of padding, one bit of padding there. What am I doing? My Viming is failing. And no, I want these to be on stop it formatter. I want to like have it laid out and then assert. Whew. To do, thank you. No, what was that? What was that? To do. Can I give it a string? Implement me. Oh, yeah. Implement rendering. Okay, I like that. I like that. I mean, that's trivial to add in Scala too, but it'd be nice. Yeah, no, formatter versus Vim, and formatter is winning. Sorry for missing all of your hints to use to do as I stumbled forward. Still have got to get better at expanding my peripheral vision to the chat area, which it flashed or something dramatically. Okay, so we want to get something like this. And I think we can make some progress there. We'll see how much, I don't want to take up too much of everyone's time this lovely day. But, oh, now I'm not using panic, I guess, so I can get rid of that? Okay, cool. So what we're going to want to do is just have make a buffer thing, which is basically going to be you could think of it logically as a two-dimensional array. That'll be the size of your terminal. And the origin is at the top left corner of the screen. Great. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and whatever, 0, 1, 2, 3. I'm not going to, I don't want it to be that big. But you get the idea. Cool. 0, 1, 2. Maybe I'll do it like that. Sweet. And so we want to basically write for this. We want to write hello into that buffer at the right place. I guess starting from the origin. I guess the top left. And we want to make sure it appears correctly inside of that buffer, which we could think of as a two-dimensional array, or how we're going to represent it is as, instead of having, you can still index into it with a y and an x coordinate, or a column and a row coordinate, however you want to think about it, whatever's the least confusing or the most intuitive to you, but we'll just wrap this up into, like, say if it ends here, I guess I've made that 4 rows. It would actually just be a straight on array like this. So you can always represent a 2D matrix as just a single dimensional vector, right? This is all, but the magic behind all that AI panel on the right-hand side. You can just view matrices as different dimensions, cubically, whatever, just collapse them. You just have to remap indices, essentially, into a flat vector. So, and there's some really basic math for doing that, but it can be a little mind-bendy if you're not used to it. I'm probably going to fail a little bit and just have the AI do it for me anyway. But, if you want to go to, let's say 0, 4, right? Here, row 0, column 4, I should do it like that, or row 0, column 3, since I moved it. Well, that's easy. You just go to the third position in your flat array. But if we want to go to where this L is, which is in row 1, column 3, well, that's all the way down here now, which is basically you just have to, it's going to be in this third area, but first you have to account for the whole first row. So you basically take the row, whatever row you are on, and multiply that by the width of the rectangle you're trying to represent. So because it's an offset of 3 after we account for all this, so it'll be 1 times the width. It'll be your row number times the width plus your column number. Row times width plus col is, and I don't need the parentheses there, but just for understanding it a little bit, that's how we can store everything in this flat vector, which is going to be way faster to look things up in constant time. Flat arrays are good. And now I'm going to look at the chat because I've just been rambling, and probably you all know this already. But if adding padding results in more space than the size of the buffer, what happens? That's a great question. I'll get to that in just one moment. Just lay it out as an array and index to point to index. Yeah, yes. I know it's trivial. It's trivial to some. It's honestly, I had to remind myself of it. It's easy to, if you don't do it a lot, it's not like the most intuitive thing in the world, but I'm sure we've all done it at some point. Or maybe not. When I first started programming, it was just like all terminal games and Minesweeper and things. So I probably would have been way better at it 8 years ago or something. Yep, cache locality as well. Yes, I did not mention that, but yeah, really important. Yep. Oh, cool. Yeah, I've flirted with making some 2D games, but I've realized that it seems immensely effortful and time-consuming. And yeah, I spent like half a week once just making a little cowboy run across the screen and blind everybody. That was going to be the whole gimmick. He would just, you'd be walking around like a top-down view, and then he'd approach an NPC, and he'd be like, oh, what's going to happen? There's an interact button, and then you press a button, and then you steal their eyes, and you get this eye counter that suddenly appears and says 2 eyes or something, or it's like, mine. I think he said mine. And yeah, I made that. It only made 3 NPCs. You could take their eyes, and they start crawling away with a trail of blood. It was very, very dark. It made me laugh, kind of, but it also made me sad because it took so long as a gag that I showed my wife when she got home, and she was very impressed. But anyway. Oh, yeah. Oh, roguelike to teach. Oh, that's awesome. Yeah, roguelikes are fun. I've not done that yet. But actually, that was my first exposure to Rust. I briefly scanned over that, like, write a roguelike and Rust thing. Except that particular one wasn't very fun. But I'm sure you can have a lot more fun. Anyway, so that's what we need to do. Let's make a buffer. And to keep it really simple, we're going to want to get more complicated, because eventually for each character, each position in this, like, terminals aren't just gray. They have some amount of pizzazz. They have colors and boldness and various other crazy antsy versions of CSS modifiers. You can make things blink and flash and invisible, and ooh, it's crazy. But we're just going to worry about characters for now. So every position, every element in this vector should be a single character. And of course, it can also be an emoji, which is like, that's where we're going to have to think about graphemes and things, and Unicode and versus ASCII and all that stuff. And it's just a big bucket of worms. So we're not even really going to worry about that first pass. But if this were going to be very robust, we would want to, to do worry about worry about that stuff. And then I'll have an emoji pointing to the left. Yeah. Oh, that hands-on Rust, is that the one? It got me, it was like a nice exposure to that it's a language. But yeah, it was kind of just like, do this, now type this, now type this, use this library that does a lot of stuff. Yeah, true. Oh yes, the actual hands-on Rust is good, not necessarily the book entitled hands-on Rust. Unless, I mean, it wasn't awful. I shouldn't put that out into the world. I'm sure it was a lot of work to write. Rustlings is an introduction. Oh, hello, Stuart again. Welcome back. I think it uses Bevy or another. In the version I read, it may have been like a pre-Bevy thing, but some kind of ECS framework. So I'm going to say it cells and not just have it thought I wanted to do the 2D array. And eventually it'll be cells, but I'm actually going to have it just, I'll call it cells for now. But each one will be a string. I think that's okay. Right. Once again, there's like, is it a borrowed string? I don't think so. I think it's just going to be a string, but we'll see. And this is going to have a very simple API for exactly what you were saying before, Matthew. So create a simple and trimple that has a few methods. Index to point that returns a new point type. Point to index that maps the other way. Set car at x, y that writes the given car to the position. Yeah, let's go with that. A simple impl. I love it. Yay. And it made a point, and it made a good point. And indexed a point. Let's just check. So yeah, it's doing that modulo math. We do have to make sure that this, I'm sure it's consistent with itself, but we just have to make sure, how is it mapping the x to the y? Whatever. I guess if we just use the interfaces, we don't even need to think about it. We'll see what happens when it gets rendered to the screen. So yeah, index modulo width, and then y. So yeah, it seems like rows yeah, we're multiplying you can think of y as rows. So kind of what I was saying before, row times width, y plus x. So that seems reasonable. And then going the other way to get a point out if we want that at some point, and then set car at. Let's see what this is doing. So this is some rusty stuff. Should return an option, by the way. Totally true. This is not safe. I think I want to keep it not safe for the minute, only because this buffer is going to be sort of an internal detail. And to kind of go back and answer Yash's question about how are we going to ensure that if you pad something, if adding padding results in a simple impl of if adding padding results in more space than the size of the buffer, what happens? And basically, what we're going to do is, where was it? When we call render, we're actually going to first get the size of our thing. Let size. So proposed size is actually going to start out as kind of like the screen size, your terminal size. Terminal size. For now, I'll just pretend it is exactly this. So we're going to offer our view the entire terminal. So have at it. Take as much of this land as you want, and no more. And hopefully our implementation of views will know to truncate themselves at the boundaries of that space. And if not, we'll have a bug, of course. But I'd rather just to have panics, I guess, in this case, and just test it with fuzzing and craziness to make sure that our implementation is correct, rather than adding an option because, oh, that's going to be right, that's going to be an allocation or something, or whatever. That just seems like a more fun thing to do. So that's my plan, at least. But I think, yes, if this were something more user-facing, that totally isn't, it's dangerous. Yeah. But yeah, anyway, I think I've been going for an hour and a half, and I don't want to take up everyone's entire night, and that was really fun. But this seems like this. I feel my energy slightly flagging, and this is like a nice breaking point. We're at a boundary where we're about to write and render this. We had a good series of fun diversions, and I learned a lot, and that was super fun. So yeah, I hope. Thanks for stopping by. Yeah, thanks, Matt. It was great chatting. Always enjoyed your internet postings. So yeah, see you around. Come back soon. I'll probably do this again another night. I don't know how often. I've been doing it every night now because it's kind of addicting, but we'll see what happens. Yeah, thanks everybody. I'm going to hunt for the button that stops the stream. I don't know where that went. No, now I'm hearing myself. No, I'm so bad at streaming. Oh no, why am I hearing myself?
Oh, there's a very low latency.
Did I stop streaming? Am I still here? I honestly don't even know what just happened.
Right in one.
Oh, okay. I'm assuming I'm still streaming. I'm trying to come back to you all so I can say goodbye and actually click the end button. And oh, I am live now. It says I'm live now. Okay, I made it to the screen. Thank you, everyone. That was a blast. Come back soon. And yeah, have a great night, everybody. End stream.